Assalamualaikum and good day. We still continue our discussion in respect system by the Bayesian rules. Okay, now we look at the example. We try to we understand already how to use the Bayesian rule in the respect system. But now we look at what is the drawback of using the Bayesian system method. The framework for the Bayesian reasoning actually required probability values as a primary input. Okay, you need to have a probability value when you use it in the expert system as a primary input, where the assessment of this value usually involves human judgment, and most of it is just based on the human judgment. Means that we know that, however, the physiological research shows that human cannot elite or require or gain probability values consistent with the Bayesian rules. This is the drawback because we cannot have a consistent value with the Bayesian rules, where this suggests that the conditional probability may be inconsistent. Due to this, uh, makes the conditional probability may be inconsistent with the prior probability given by the expert. The prior probabilities actually is the one that we give to the is given by the expert. Now we try to look one of the example to show that why it is not consistent. We consider, for example, a car that does not start and makes odd sound noises when you press the starter. Okay, so the conditional probability of the starter being faulty, you want to identify either the starter is faulty. If the car makes odd noises, may be expressed as, okay, if symptom is odd noises, then the starter is bad. You give the probability 0.7. If symptoms is odd noises, then the starter is bad. Okay, now we look. Then we need to consider, for example, a car that does not start and makes odd noises when you press the starter. Okay, before this, car does not start and makes odd noises when you press the starter. So the conditional probability for the car being faulty, the starter being faulty, if the car makes odd noises, you may express it as the starter is not bad. Uh, why it is produce odd noises. So the conditional probability the starter is good, the other way around, that it provide odd noises. So it become 1 minus by 0.7, where you put, when you assume the first rule, then you got 0.3. So you understand up to here means that you got only 0.3. So therefore, if we can obtain a convenient rule that states eh, if the symptom is odd noises, then the starter is good. Okay, so we put with a probability 0.3. So the domain expert do not deal with the conditional probabilities and often deny the very existence of hidden implicit probability. So in this example, is 0.0.3 is too small compared to the 0.7. We would also use available statistical information and empirical study to derive the following rules. Okay, let me say if the starter is bad, then the symptom is odd noises. So probability is 0.5. If the starter is bad, then the symptom is not odd noises. The probability is 0.15. Okay, so this is the one that we use the statistical information. So to use the Bayesian rules, we still need the prior probability, where the probability that the starter is bad if the car does not start is suppose the is supplied by the expert, the value is 5%. Okay, the value is 5%. So the probability that the starter is bad if the car does not start. Okay, now we can apply the Bayesian rule to obtain. Okay, use the Bayesian rule to obtain. The starter is bad and it produces the odd noises. Okay, this is the equation of the Bayesian rules, okay, as we derive it from the previous rules. Okay, 0.05, the 5% that being supplied by the expert. So as a result, if you look here, this is the uh, conditional probability. And this is not, okay, this is okay, the number obtained is significantly lower than the expert estimate. Okay, in the beginning, if you look back when we mentioned about the starter is bad because of the odd and produce the odd noises, we get 0.7, okay, given at the beginning of this session. So the reason for the inconsistency is that the expert make different assumptions. Okay, it didn't consistent, it make a different assumption when assessing the conditional and prior probabilities. Okay. It gives the different assumption when you try to assess the conditional and prior probabilities. So this is the drawback of the Bayesian. Uh, then we have another method where we use a certainty factor theory and evidential reasoning. So this is the other way of applying the expert system. Okay, so certainty factors theory is a popular alternative to the Bayesian reasoning. This is other option where you can use it. Okay, a certainty factors, factor number to measure to measure the experts' belief, where you can have a maximum value of the certainty factors, say at positive 1.0, which means definitely true. And also we can have a minimum negative 1.0 where it is definitely false. For example, if the experts state that some evidence is almost certainly true, so we can put the certainty factor value can be 0.8 would be assigned to the evidence. To the evidence. Okay, MySIN is one of the expert system being developed to diagnose. I forgot already to diagnose certain diseases. I know to due to the bacteria problem. Okay, certain terms and their interpretation. We have the term from definitely not and definitely. Okay, but the arrangement due to the when I'm copying this, the table is not aligned with the terms, the certainty factor. But you try to make it align. And the other thing is definitely not actually start from negative 1.0. Almost certainly not is negative 8. Probably not is negative 6, and so on. Where definitely is positive 1.0 and almost certainly is positive 0.8. These are the terms and the interpretation that we use in expert system. The certainty factors that knowledge base consists of a set of rules that have the following syntax. It is how you write the same as the Wilson rules. Then you have evident, if evident, then hypothesis, and you put certainty factors. Where certainty factors represent belief in the hypothesis H, given that evidently has occurred. So it represents belief in hypothesis H, given that the evidence has occurred. Actually, the certainty factor theory is based on two functions. You have two functions. The first one is measure of belief, we call it as MB, H hypothesis evidence, and measure of disbelief, we call it as MD, okay, function of hypothesis and okay, if you look here, measure of belief, you have a function. If the probability of uh, hypothesis is equal to 1, then measure of belief become 1. Or otherwise, you need to calculate, find the maximum of the either PHE, conditional probability and probability, minus which one is highest, minus a of sorry, which one is highest, minus probability of H, and then maximum 1 or 0, and then minus with pH. Okay, this is for a measure of this belief. If the pH, okay, the probability of hypothesis is equal to 0, then the measure to this belief is 1. And this is for the rest of it. We are going to look into example later on. Okay, pH is the real probability of the hypothesis H being true, and pH for E is the probability the hypothesis H is true. You don't get the evidence in circle. The values of measure of belief and measure of disbelief actually range between 0 to 1. Okay, we have from 0 to 1. The strength of belief or disbelief in the hypothesis H depends on the kind of evidence E observed. Okay, you check the evidence, okay, how you want to look at the strength of belief or disbelief in the hypothesis H. Some fact may increase the strength of belief, but some increase the strength of disbelief. I mean, there will be, you will notice that there will be some facts where can increase the strength of belief. I mean, measure of belief will be increased. But other fact also can make the strength of this belief also can increase. The total the total strength of belief or disbelief in a hypothesis uh, we can calculate the certain. Okay, we have a measure of belief minus by measure of disbelief. Then 1 minus by minimum between measure of belief or measure of disbelief, whichever is the minimum. This is how we calculate the certainty for the hypothesis. Okay, let me look at an example. If we consider a simple rule, if A is X, then B is Y, where an expert may not be absolutely certain that this rule holds. Also, suppose it has been observed that in some cases, even when the if part of the rule is satisfied and the object A takes on a value X, object B can acquire some different value as well. Okay. It might be Z. So this is how you written in the so you have this is from the simple rule. Expert might say that if value A takes if A takes the value X, so there might be uh, 0.5 certainly factor for B to get Y and 0.2 certainty factor for B to get Z. So the certainty factor assigned by a rule is propagate. You are going multiply for each of the roots. Okay. This is a certainty factor we are going to discuss. Okay. If sky is clear, for example, then the forecast is sunny, we give a 0.8, 0.8 certainty factor. And the current certainty factor of sky is 0.5. And this is given uh, by uh, by the observation. So certainty factor of the forecast, the forecast is sunny, if the sky is clear, is equal to 0.5 multiplied by 0.8, then you get 0.4. So as a result, actually, we can interpret it as it may be sunny. For a conjunction rule, such as, okay, we have a conjunction rule, either and or or, we have first evidence, second evidence, all the evidence that when we and it and the hypothesis, then how we calculate the certainty factor. The certainty factor of the hypothesis is established as below. Okay, you will find from the certainty factor for the hypothesis given the evidence 1, 2, 3 until n. So you will find the minimum certainty factor of between all of it, the minimum one. Okay. Let me look at the example. If the sky is clear and the forecast is sunny, then the action is to wear sunglasses, given by 0.8. So let's say the sky is clear, certainty factor is 0.9, and the certainty factor that the forecast is sunny 0.7, then based on uh, the conjunction rule. So the certainty factor of the action is to wear sunglasses given the evidence 1 and evidence 2, which is the conjunction rule, and so you need to identify, okay, from the certainty factor of the sky is clear and forecast of sunny, forecast of sunny 0.7. So you have to find the minimum one. Okay, between 0.9 and 0.7. Actually, 0.7 is the minimum. You multiply it by certain factor of action to wear sunglasses, 0.8. So 0.7 multiplied by 0.8 is 0.56. Minimum. You will need to find minimum between all the evidence. Okay, in here we have two evidence. So evidence 1 and evidence 2, which we have 0.9 and 0.7. So 0.7 is the minimum one. Use the 0.7 multiplied by the certainty of the hypothesis. Then we get 0.56. Okay, for disjunction rules, we have if evident with all the evidence with all, then the hypothesis. So the certainty factor of the hypothesis, the certainty factor of the hypothesis is as follow, where the certainty factor of the hypothesis given evidence 1 until evidence n, then we use the maximum between the certainty of the evidence to calculate the certainty of the hypothesis. Okay, if we have an example here, if the sky is overcast and disjunctive rule is or the forecast is rain, then take the action is to take an umbrella, and we put the certainty factor to take the umbrella is 0.9. And the certainty of the sky is overcast, let's say, is being given 0.6, and the certainty of the forecast of rain is 0.8, then the certainty factor of the hypothesis take an umbrella given the evidence overcast and rain, you need to find the maximum certainty of between the overcast and the forecast is rain. So in here we have 0.6 and 0.8, then we need to take 0.8, the maximum. If the maximum, then we can get 0.8 multiplied by 0.